Hello and welcome, listeners, to another episode of Field Notes, a weekly podcast from the Hindu business line on all things agribusiness. I'm your host, TR Vivek. Field Notes is, of course, available on our website, www.businessline.in, and you can find us on all the platforms you get your podcast downloads from regularly: Apple and Google Podcasts and Spotify. Now you can also watch the show on Business Line's YouTube channel. Please do subscribe to us or follow us on the platforms of your choice. If you have feedback or comments or would like to hear on any issue in particular, you can write to me. My email is in the show's notes. Right then, I promise you this is going to be a very special show, one that I'm personally very excited about. Today, we'll be talking about fertilizers and about a new Indian invention whose market potential could run into several thousand crores. India uses about 60 million tons of fertilizers annually. The government spends nearly 1 lakh crore rupees in fertilizer subsidy, or just about 7,000 rupees per farmer. This acts as a perverse incentive sometimes for farmers to use fertilizers far, far in excess of what would be optimal. The indiscriminate use leads to soil infertility, and the fertilizer runoffs end up polluting our precious water bodies and harms human and animal life. To reduce the usage of urea, the chief fertilizer, IFFCO, or the Indian Farmers Fertilizer Cooperative that produces and markets them, has a few days ago commercially launched the Nano Urea in liquid form that can reduce the need for solid urea by up to 50%, or nearly 14 million tons, saving the farmers about 28,000 crores annually. Says that this is that the commercial production of nano urea marks a big scientific breakthrough, such product in the world. Talk us about this, we have Dr. Ramesh Raliya, the inventor of Nano Urea. Ramesh Raliya is currently the general manager of IFFCO and the head of its nanotech R&D center in Gandhinagar. Raliya comes from a farming family from a small village in Rajasthan's Jodhpur district. He received the patents for the Nano Urea while doing his research in Washington University at St. Louis in the US. Dr. Ralia has given or he's given the license or licensed his inventions to IFFCO for the benefit of Indian farmers virtually for free. Dr. Ralia, how are you? And welcome to Business Lines Field Note.
Thank you for having me here.
Dr. Ralia, yours sounds to be a very, very inspiring story. First, before we get to that, tell us about what is this nano urea and why is it so important? Why is IFFCO so excited about it?
Nano urea is a nitrogenous fertilizer. It provides nitrogen to the plant
Mhm.
when sprayed on the crop leaves. It has a special feature that this urea nitrogenous fertilizer is converted into nanoscale, and nanoscale is 1 nanometer is 1 billionth of the meter. So it is
Mhm.
very fine, very small size particle. When we spray these particles on plant leaves have small openings that is called stomata. So plant leaves can uptake these particles efficiently, and this nutrient can be provided to the plants. So this nano urea IFFCO is very excited about because of two reasons. One, that it will require less to produce same or more what we
Mhm.
are producing with conventional urea, and second, uh, that it will minimize the environmental runoff of nitrogenous fertilizers. So that will help our environment, that will increase the efforts towards environmental sustainability through agriculture. As we all know that conventional urea, 60 to 70% getting runoff into environment, and it causes into greenhouse gas emissions, whether it is nitrous oxide or ammonia emission that affect our environmental health.
Mhm. And IFFCO, as a producer of fertilizers, has been campaigning or trying to reduce fertilizer consumption in the country. In several states like Punjab, where the per capita consumption of fertilizers is as high as about what 200, nearly 250 kilograms per hectare, against a national average say of about 150. So things are very serious on this front. And so how does nano urea bring down the consumption of conventional urea, and what is its commercial potential?
As you rightly said, that the huge ratio of fertilizer mainly considered as NPK use ratio. So it is highly skyrocketed when we compare to the national ideal average. So for that reason, that high use of chemical fertilizer are affecting our soil health as well.
Mhm,
Like for example, using high amount of urea it is affecting soil pH, and the influence of soil pH also influence the nutrient uptake of other micro and macronutrient for the crops.
mhm,
Using this nano urea, we can reduce the consumption of conventional urea by 50%, which is broadcasted after the seed germination.
mhm,
So what we can do that in is we can reduce the 50% of conventional urea and then use the nano urea instead of that, and that will save the cost for the farmers from the agriculture input perspective, but it will have large benefit from the environmental perspective, from soil health perspective, from increasing the crop productivity perspective.
mhm, mhm. So I'm told that 1/2 liter bottle of nano urea is equivalent to about 45 kg bag of conventional urea. So that has huge implications for in terms of transport or storage costs. Can you show us a bottle if you have it handy?
Absolutely. So you can see a half-liter bottle in my hand. It
Mhm,
is just 500 ml bottle,
mhm,
uh, and the impact that we are getting from a 45 kg bag on the
mhm,
crop, the
mhm,
same impact on crop response we can get from this 500 ml nano urea product when we spray through foliar applications.
mhm,
Uh, so this will, as you mentioned, it will help uh, storage and transportation. And through transportation, it will further help in the environmental pollution management perspective.
mhm,
Because today, if we talk about one bottle is equal to one bag, like in terms of its impact. So if I have to send, let's say, like 1,000 bags of urea, 1,000 bag of urea for a village, uh, farming unit as a village, I need a big truck for that.
mhm,
And if I have to send 1,000 bottles, I can send just through a courier.
mhm,
So that will help in very big way from the logistic perspective, from transport perspective, and further it will help that we can also send to the hilly regions where like transportation is not an easy task.
mhm,
And that one more benefit I would like to mention, that the conventional urea typically farmers buy and utilize in the same season,
mhm,
because if they keep that urea bag storage, then this urea get agglomerated, urea granule become agglomerated, or if there is high moisture, it affects the quality. But in this case, because it is in bottle and these particles are very stable up to 2 years.
mhm. Is this truly a first of its kind product in the world? One would imagine that large agrochemical companies or agri-tech companies like Bayer or Syngenta would have been working on something like this.
uh, I cannot name any organization because I'm on in an organization, but I can
Mhm,
say that many companies are working on nanotechnology based efforts
mhm,
for agrochemical and agricultural uses, whether it is
mhm,
pesticides, herbicides, or fertilizers. So they are working on that. But this Nano Urea IFFCO is the first organization who invented, developed, and commercially translated this product first time in the world.
mhm, mhm. Uh, Dr. Ralia, uh, tell us about why is conventional urea so harmful for the ecology, and how does the usage of nano urea how does it mitigate those ill effects?
So, if we talk about conventional urea, the harmful impact comes with two. One is the use efficiency is less, and
Mhm,
then using in very high amount.
What do
When
you mean efficiency is less?
efficiency is less means when we broadcast the conventional urea on the crop,
Hmm.
plant only take 30 to 40% in best
Hmm.
cases.
Hmm.
So let's say I apply 100 kilogram of urea, plant will take just 30 to 40 kilogram of that. So
Because
60 to
it's thrown on the soil. It is distributed,
yes, yes. So
sprayed on the soil.
I can describe little of that mechanism that when we throw the urea granule on the soil surface, there
Hmm.
is an enzyme called urease. That
Hmm.
urease enzyme basically break down or hydrolyze that urea granule, or that get because of the moisture that get hydrolyzed, and then
Hmm.
plant uptake in form of ions. So during this process, because it is an open atmosphere, so it gets reacted with the environment and it convert into nitrous oxide,
Hmm.
or it get volatilized and emit in form of ammonia gas,
Hmm.
or it get leaches and enter into our groundwater, where it contribute to the nitrate contamination.
Hmm.
So if we use in excess amount, if it remain in the soil, it will influence the pH. Our soil become more acidic,
Hmm.
and when soil pH get changed, it affect the other nutrients, because plant uptake all the nutrients based on the soil rhizosphere pH, because all the nutrient uptake is directly related with the pH of the rhizosphere and the
Hmm.
concentration of that nutrient in the plant cell. Second, if it emit in form of ammonia as an emission, and that contributes in form of NOx to the environmental pollution. And the second is nitrous oxide emission, which is one of the potent greenhouse gas. And nitrous oxide is 300 times more potent than carbon dioxide that we talk about when we talk about climate change or global warming or greenhouse impact.
Hmm.
When we use nano urea has high use efficiency. Its use efficiency, when we apply through foliar application, the use efficiency is over
Foliar,
85%.
by foliar application, you mean that sprayed in the form of a
Spray,
liquid on the plant itself.
yes, spray on the plant leaves.
Okay.
So when we spray these nano urea on plant leaves, its uptake efficiency is better. So plant use it very efficiently. And then when we spray, they are in the particle form,
Hmm.
not in the ionic form. So these particle form uptake by the plants through on the plant leaf. There is a small structure, hair-like structure that we call hydatodes in the scientific term, or small pores which we call stomata. So
Hmm.
plant uptake these nanoparticles through those, and then once it is enter inside the plant cell there is a transport mechanism that is called
Hmm.
phloem translocation mechanism. That these are basically that certain small micro tube like structure. They transport the nutrients based on the plant's requirement. So that
Dr. Ralia, in layman terms, would it be like taking an intravenous injection rather than popping a pill in its immediacy and efficacy?
yeah, you can say that.
Mhm.
You can say that it's an intravenous injection, basically going directly into the cellular part of the plant. And another
Okay.
thing is passive uptake, which you have compared with the capsule.
Okay. Okay. Dr. Ralia, tell us about tell us about your own research and interest in this area, and how you ended up working with IFFCO. Because you conducted your research in Washington University in St. Louis after your PhD in India for your postdoctoral research. So tell us about and your patents involving nano urea as well.
Uh, so I born and raised on a farm field. My parents are doing farming, and since childhood, I have seen that my parents are buying fertilizer in more and more quantity every year, and productivity is near or more less, same amount.
Mhm.
So when I enter into like in higher secondary school, started understanding about plant biology. Then I did bachelor's in botany, then master's in plant biotechnology. At that time, I started understanding about the nutrient use efficiency, the efficiency of fertilizers, and like that.
Mhm.
That basically instigate me to do PhD in nutrients. So I applied for World Bank funded project, that is National Agriculture Innovation Project of ICAR, Indian Council of Agriculture Research. And in that, we have worked on several nutrients which can be synthesized at the nano scale using microorganisms.
Mhm.
We used rhizospheric fungus and bacteria to synthesize those nanomaterials and then spray of those nanomaterials on plant leaf and uptake. And
Mhm.
that basically lead me since 2008 that these nano scale particles has potential to increase the use efficiency. And when we compare them with bulk, they require in less amount, but they are giving equal or better impact than the conventional fertilizer of their bulk counterpart.
Mhm.
And when I went to Washington University, then I took a task that how can these particles scale up at the industrial scale? Because at research scale, we make the materials in milligrams, in milliliters, but then whenever we talk about agrochemicals, they require in tonnage or
Mhm.
metric tonnage or mass metric tonnage. So I tried very like different methods to manufacture these nanoparticles. I used chemical synthesis, physical synthesis, uh, biological synthesis, and aerosol synthesis.
Mhm.
And among that, we were able to get success in terms of making these nanoparticles at large scale amount and with a cost effective technology.
Mhm.
Then at that time, I was having that feeling for the nation, and I told my parents that I have developed such fertilizer, which like you guys are keep buying in bags and bags, and that is not useful for the crops. Majority of the part you are putting into the environment. Then my parents says that, like, can you send us something? Then I told him that it's just an half liter or kilograms you can put into a large field. Then they were saying that it cannot be real. Maybe like
Mhm.
something you are joking. So then I really sent that sample to my parents, and I requested them that 1 year for one season you take a risk on my name and put into the field. And ultimately they found very good result. And that basically replicated my farm trial in United States. I replicated that trial in India. Then I thought that how can I help like farmers like my father across the country? Because more than 50% of Indian population is directly doing the agriculture, and large part of people and their employment is depends on agriculture. So I wrote a letter to Prime Minister in 2015 that I have developed such nutrient fertilizer, and this nanotechnology should be used in fertilizer and also in education as well.
Mhm.
Then ultimately, I received an invitation in 2017 from Prime Minister Office and Ministry of Chemical and Fertilizer Government of India that you
So
come
you're
and
telling
give.
me that your first communication did not elicit any response. So you kept on writing. Probably you succeeded at getting a hearing at the third time of asking. Is that right?
Yeah, so I wrote in 2015, then I wrote in 2016, and then 2017.
Mm-hmm.
Except 2018, I'm writing letter to the Prime Minister Office every year to get that until I return to India.
Mm-hmm.
So in 2017, actually, they responded and they asked me to come and give a presentation. And then I gave a presentation in front of Secretary Fertilizer and the industry leaders of India's fertilizer industry.
Mm-hmm.
And among them, two industries were there. Among two industries followed it up back with me. Among that, one was IFFCO.
Mm-hmm.
Uh, then IFFCO officials visited me in St. Louis,
Mm-hmm.
and they have seen my field trials. They have seen the way I was working, our laboratories and our scaled up things. Then they asked me that can we like have that association.
Mhm.
And ultimately, like I came to meet IFFCO management. I gave my presentation to them. IFFCO's managing director asked me that how big you know about IFFCO,
Mhm.
like because I was thinking that IFFCO is a government organization. Then he asked me the question that how long and you know about IFFCO. Then I told him that I know IFFCO because in my childhood, when I was a school kid, then our family economic situation was not that great, and I my family couldn't afford even the school bags, fancy school bags, but I
Mhm.
have used the urea bag or DAP bags as my school bags.
Mhm.
So, because they are like water resistant bags like that. So then like Dr. Avasthi ensured me that if you get associated with IFFCO, we can have this fertilizer, most technologically advanced fertilizer for farmers.
Mr.
Uh,
Avasthi would be the CEO and managing director of IFFCO.
yeah, he is the CEO and managing director for IFFCO. But I also showed him the letter which I have mentioned to the Prime Minister, that in which I mentioned that if Government of India utilized my knowledge and technology, I will transfer that technology at free of cost if Government of India give this fertilizer at the very minimal or very minimal cost
Mhm.
of production, at the cost of production only. And then IFFCO had that commitment to provide the fertilizer to the farmers of India at the very affordable price, like nearly at the cost of production. So that basically inspired me to join this organization, and we worked here. We developed this product, and after that we launched nationwide trial in 2019.
Mhm.
We have
So
tested this.
let me get this right. So this was the precondition you set to the government of India, that you would give them the technology for free, if provided they in turn provided this to the farmers at cost price, or at reasonable cost, not market prices.
Yes, I have sent in the writing to the Prime Minister office that if Government of India utilizes my technology, I will give at free of cost this patented technology.
Dr. Alia, this almost sounds insane. You're a young man. You're 33, and working at leading research institute in United States. And if indeed this is a breakthrough technology, you could have had large companies queuing up at your doorstep, wanting to license it, and probably employing you at 6 or 7 figure salaries.
Uh, See, I always believe like being born and raised at farm family, I always learned from my parents that money is not everything. What we can provide in terms of service uh, to the community, that's the big thing. And for me, the community is entire farming community. When I was in US, I developed a startup company there to having help of this advanced technology to the all the farmers of the world. Even
Mhm.
still, I dream that my fertilizer will reach to all the farmers of the world at affordable price. So I did not consider money as the priority. I consider that how my technology can help the farmers, because by studying well, by having a good job, I can transform my own lifestyle. But if I cannot transform the lifestyle of my fellow countrymen or my fellow community members, it means that I am failed at the community responsibility. I may have succeeded at the personal goal or personal level, but I am failed at large. Because when you have no, I believe that when you have knowledge, when you have empowerment, then you have another responsibility to make others empower through your knowledge or through your resources. So that's what I have learned, that whatever the resources in terms of knowledge or other resources, if I don't share, then there is no value. So that's why I believe that even if I just need a money which I can survive, but the other things I should donate or I should give away to the farmers. And this is not giveaway, because as a scientist, I feel that this is not an giving away, but this is an investment. This is my investment for my environment. This is an investment for my country. And the realization maybe happened after 5 years or 10 years, when like that's what like I'm dreaming, that if India started producing this nano fertilizer, and recently IFFCO gave this technology to the National Fertilizer Limited, Rashtriya Chemical Fertilizer Limited, and all farmers are getting this. Today, India is importing urea, some major part of urea we are importing. If India stop the importing, I can see what kind of relief moment for me, that India will save thousands of crores. And those thousands of crores, if can be spent on farmers, let's say to save their, to waive off their farm loans or some other things, that will be a big relief for me. That's a big check for myself. And if my products can bring an smile, that is the money, or that is the thing I have. Anyone can smile because of my work. That is the more bigger money than just a paper having certain value.
Mhm. No, that's really inspiring and humbling. Dr. Ali, did large global corporations did they approach you? Were you in touch with them with regards to developing this product further?
When I was working at Washington University, I was in touch with more than 60 countries, and you can imagine the number of companies working in those countries, whether it is Middle Eastern, whether it is China or US companies, or the European companies and the companies who work in African countries for the trials and tests. So I was in touch with them. Many people have offered uh, many things, but I was having certain terms and conditions, that like my first and foremost condition was you have to provide the fertilizer at the affordable cost to the farmers.
Mhm.
Like when we talk about uh, democracy, I use in terms of technology is a technological democracy. You can
Mhm.
develop a technology, but unless and until everyone can access it, it has no use. So we
Mhm.
have to develop the technology, but also make it accessible to the poorest person. Then it's a real worth for that.
Mhm. Mhm. So something like this, I imagine, would be rather expensive if the government hadn't decided to sell it to the farmers at cost price. Say if it were in the hands of a large multinational company, it would fetch a decent price, I suppose.
Uh, like I would say in the United States, we were putting the cost of production is around like selling price. We were estimating the seed that we have developed is about $1,600 for a
Mhm.
liter. So sixteen
Okay.
hundred dollar is about 1 lakh rupees plus, I believe, in
Mhm.
Indian currency.
Mhm. Mhm.
So it would have been very costly if it had been through like some other means. Uh, but like when we go for scale up, we can use certain technology, certain approach to make the things affordable.
Mhm. Mhm. Dr. Ralia, tell us about the results of the tests that you conducted, in India for this product, and what kind of productivity improvements did you notice, and what was its efficacy?
We tested this product on more than 11,000 farmers field. We collaborated with Indian Council of Agriculture Research Institutes and state agricultural universities. We
Mhm.
tested this on 94 crops. And what we have found that when you reduce the conventional urea by broadcast by 50% and use the nano urea, your on an average crop yield will increase by 8%.
Mhm.
Uh, we have also tested in certain conditions the 100% replacement, but current recommendation is the 8%, 50% replacement of conventional urea and use of nano urea. Because the reason is that country is also producing urea in certain amount, and also our long-term trials, like long-term trials are ongoing. So that's why we are gradually introducing so that it can easily be accepted by the farmers, can be practiced by the farmers.
Mhm. Mhm. And you were telling me that in the case of some horticultural produce, the efficacy is even higher. It
Yes.
can go up. It can go up to about 25%.
Yeah, so we have tested on like cabbage, we have tested on chili, on tomato, cucumber, potato. In that case, the production increased up to 25%, and that is very significant. In fact, we have tested the product quality from the nutritional parameter perspective, and we found that when we use nano urea, it basically increased the nutritional quality in terms of protein content, carbohydrate content, fiber content, and other nutritional. And because you know that nitrogen is the key parameter increasing the grain protein concentration, that is called GPC, and that is one of the nutritional parameter to determine that how nutritional rich the grains are. So by applying this nano urea, the GPC grain protein concentration is also increased.
Mhm. And now the commercial production has commenced for nano urea.
Since June 1st of this year, the commercial production has been started at Kalol, Gujarat, Gandhinagar, that's IFFCO's mother unit,
Mhm.
where the production has been started. This product, after the test and trial, was submitted to Government of India uh, for that is called Central Fertilizer Committee, and that committee has evaluated these products. And this product also tested for safety and toxicity as per the Department of Biotechnology Government of India guideline. That
Mhm.
basically tells that when you have any kind of nanomaterials for agricultural application, what kind of safety and toxicity assessment test to be done. Like for example, when you spray, this is foliar spray on the crop leaves. So it can be get inhaled, or it can be touched with the skin or eyes or nose, or in terms of runoff, it can come in touch with fish, earthworms, microbes, beneficial microbes, or like feces at the embryo stage, or larger feces, tropical feces. So we have tested this material from the safety and toxicity perspective as well as per the DBT guideline. We went little further because we also want to serve the global farmers. So we tested this product as per OECD guideline, Organization of Economic Cooperation and Development, that is
Mhm.
valid throughout the globe from the GLP practice-based test. That is good laboratory practice, that is globally harmonized protocols.
Mhm.
And this product is passed all the safety and toxicity assessment test. It's completely safe at the recommended doses.
Okay. Okay. Dr. Ralia, that was really, really inspiring. And thank you very much for joining us on Field Notes podcast.
Thank you for having me, Vivek. Appreciate.
Thank you.